I'm going to talk with you about a 2-year project that just ended, Rapid Adjudication of Static Analysis Results During Continuous Integration, or CI. I'm Lori Flynn. The problem this project addressed is that it takes too much time to adjudicate static analysis results during continuous integration. Our solution involves increasing the number of static analysis results addressed automatically by enabling optional CI integration with 2 types of automated adjudication transfers between code versions and the use of classifiers in an automatically updating system. Benefits include development of more secure software in less time at lower cost for a wide variety of static analysis tools and development systems, including modern CI systems. So, over a series of 6 years of research projects that I've led, we first created and then continued to develop the Scafee Modular Automated Classification System. We use it to implement features and then test them, and then to share the functionality with others. So as a standard part of software testing, code bases are analyzed by 1 or more static analysis tools, each of which outputs a set of alerts or warnings. Today, those must be manually adjudicated as true or false, leading to the situation that's common today where for medium and large size code bases, an enormous number of warnings are simply not examined due to the cost and not having enough money to be able to manually adjudicate all of them. In my projects, we use the term meta alert. That's a static analysis result for a particular line number, file path, and type of code flaw. Scafee classifies meta alerts as expected true or false positive if the classification confidence is above a particular threshold. The rest of the meta alerts it classifies as indeterminate, and those must be manually adjudicated. Now, high confidence classified results can be used to reduce the amount of effort used for adjudication while addressing the same number of static analysis results, or to address a greater number of static analysis results while keeping the manual effort the same. We've designed Scafee for use by machine learning novices with settings that can be tweaked by experts. Labeled static analysis meta alerts are used to create classifiers. Those come from manually adjudicated meta alerts, and they also come from test suites like Juliet, Stone Soup, etc. Scafee automatically adjudicates them using NIST SARD's formatted metadata. The Scafee user chooses labeled data sets, classifier, active learning, and other options using the simple guidelines in the Scafee manual provided. There's a modular ability in Scafee to add different types of classifier, active learning, and hyperparameter optimization methods. So with this system we've developed, Scafee is used to adjudicate and classify results for a single code version at a time in a CI optional system with automated updates to code and static analysis results. In a CI workflow, each member of a development team takes on a bug fix or a particular feature add, And when they're ready, they check in their source code to a source code repository, and then the CI server takes over. It builds, installs, it deploys, and then it runs a bunch of tests. In this project, we're concerned about the static analysis being run as part of this process. Now, you can, as we discussed before, there are too many static analysis alerts to manually adjudicate at one time. And in the short CI build times, dealing with all of those results is particularly problematic. Also, the development and test teams are especially urgently interested in fixing any failing unit integration or stress tests that come from the CI server. In most cases, the static analysis results, dealing with them is much less urgent for them. So often they're ignored if static analysis even is run during CI builds. Another issue to consider is that as a code base grows and static analysis tools are run on it during the CI build, many of the warnings are repeated as the code base grows. Not all of them, though. So there's this question of what to do with manual adjudications of the static analysis from one code version to the next. For code versions 1 and 2, can an adjudication from V1 be applied to an adjudication for V2? We call that cascading. So in this 2-year project, we work with 2 types of cascading. Imprecise cascading happens on a per file analysis and uses regular expression and or line numbers. It's sometimes incorrect, but it's really fast. Precise cascading uses analysis across a whole program using control flow, data flow, and type flow. It's more correct, but takes a long time, which is an issue to consider during the short CI build times. So there are trade-offs of each method. And one particular aspect that's important to consider for this project is that classifiers rely on their precision and recall, their performance, depends on the labeled data being correct. So precise cascading is good for classifier precision, but you've got that build time trade-off. Scafee has 5 modules: the UI or user interface, registration, prioritization, the data hub, and statistics. This modular architecture enables it to integrate with many tools and systems, and its Open API v3 definition enables automated code generation in many code languages. Any static analysis tool such as SEI Scale, DHS Swamp, etc. can instantiate APIs to become a UI module. Now, as a result of this project, Scafee can be integrated into CI workflows. These new capabilities make static analysis classification more practical for people to use. In this figure, you can see the dashed lines where we've added new API calls. And now there's this, there are these optional calls to a code repository server and CI server. So in FY21, we integrated diff-based cascading into Scafee, generated diff-based cascading test data, and in collaboration with Dr. Wei-Lei's team from Iowa State University, we developed a precise cascader and generated test data and compared precise and diff-based cascading. Recently, we released Scafee version 3. It has enhanced performance metrics collection, an experiment mode. It auto sets up experiments with config files and data sets, does metrics collection, auto ends, and exports data files. Metrics include classifier precision and recall, counts of adjudicated versus high confidence, predictions at particular time periods, latencies, CPU use, bandwidth, and memory use. Java test suites are now fully usable by Scafee, and we've enabled CI integration and have 4 hands-on CI demos as part of it. They were first released in the Scafee v2 release earlier this year. SEI-CI experts who did not develop the Scafee system did run the CI demo and verified that Scafee updates worked with their server and Git repository. External collaborators verified that the CI demo and performance experiment functionality in most systems. SEI and collaborators generated performance data, and we've done analysis and developed ideas for future system design enhancements, including a design for greatly reducing latency of classifier creation and use, and ideas for improving precision and recall. We've publicly published the Scafee formal API and the Scafee UI modular scale code on GitHub. And we welcome people testing Scafee. To test, you start up Scafee with a Docker compose command, as shown in the screenshot, on a Linux or Mac machine. Then select an experiment from the drop-down list. That's this thing I'm circling here. Once that's selected, the rest auto-fills. And then adjudicate meta alerts, selecting true or false from the verdict field, working from the top of the list. After an adjudication is made, the list reorders, and adjudications are made by looking at the meta alert and examining the associated code. And then finally, send the exported 3 files back to us if possible, or provide qualitative feedback on testing. So we have developed algorithms and tooling for automated static analysis handling to adjudicate more results in less time. It's now integrated with CI to keep your code secure, build by build, and to fix earlier, which is cheaper. And our overall goal is to help folks to develop more secure software in less time at a lower cost. Many thanks to this wonderful team of folks who did the work that I have that I've been talking about on this presentation. We've also developed a project concept for integrating the Scafee classification system with automated code repair, or ACR. This project concept was developed in collaboration with Will Kleber, who has led a series of automated code repair projects. The idea is development of a system that modularly incorporates a wide variety of classifiers, as well as a wide variety of ACRs, in order to automatically address more software defects while not duplicating effort and enabling improvement of classifier results using the results from automated code repair. The concept involves an ACR fix being made to the code. Then the fix is committed to the code repository, and the CI server handles the modified code as before and runs tests. And then Scafee uses the CI server updates as before. If the last code merge was an auto repair, Scafee checks if a meta alert for the repaired condition reappears on match lines of the repaired code. If yes, it auto-labels the meta alert false. And then the new labeled data, the meta alert auto-labeled false and associated data, is used to improve the static analysis classifier predictions for all the remaining not yet adjudicated meta alerts using adaptive heuristics and or occasional classifier retraining. If you're interested in the Scafee ACR integration idea, please contact us. We invite you to test Scafee and ACR tools. So thank you for listening, and questions are welcome.